99% of Earth's history was warmer. This planet cycles through deep freezes. But these ice ages, recurring epochs of global cold, shaped continents. The mechanism is astronomical, tied to subtle shifts in Earth's orbit. With these are the Milankovitch cycles: eccentricity, obliquity, and precession. Eccentricity dictates how circular or elliptical our path around the Sun is. The obliquity measures the tilt of Earth's axis, affecting seasonal contrast. A precession is the slow wobble, like a slowing top, altering seasons' timing. When these cycles align perfectly, northern hemisphere summers become very cool. The cool summers prevent ice from fully melting, starting the feedback loop. And this is the crucial trigger, the accumulation of snow over many millennia. An albedo effect amplifies cooling, bright white reflects solar energy back into space. But at peak glaciation, ice covered nearly a third of the northern hemisphere. And now that we understand the driving forces, let's explore the life that endured. The iconic inhabitants were the Megafauna, giants adapted to the cold. Their primary defense was sheer insulation, layers upon layers of specialized hair. Small ears and short tails minimized heat loss to the frigid air. A tusk served not just for defense, but for crucial foraging under snow. Prehistoric bison were stockier and possessed even thicker coats than today's species. Shelter was often found deep within caves, offering stable, warmer microclimates. Inside, early human ancestors managed fire, a critical thermal technology. Toolmaking evolved rapidly, specialized hunting implements became essential for large prey. Cooperative hunting strategies allowed success against animals much larger than themselves. Water management was equally crucial. Finding unfrozen liquid was a daily struggle. But other megafauna adapted differently, like the giant ground sloths browsing high foliage. There, immense size provided insulation, but slower metabolism demanded less energy input. But these interactions are preserved in ancient art, our clearest window to that time. The art captures not just survival, but the rich biodiversity that surrounded them. Predators faced similar challenges, relying on stealth and overwhelming power. The defining feature, those immense upper canines, were optimized for deep, quick dispatch. But the entire ecosystem existed in a state of perpetual, high-stakes tension. But even the wolves were larger, structured for greater endurance and pack hunting success. We read the past through ice cores, trapping ancient atmospheric bubbles inside. And these bubbles record precise historical levels of greenhouse gases and dust. The correlation between temperature lows and lower atmospheric carbon is striking. A massive water retention on land caused sea levels to drop by over 100 meters. This exposed connection allowed terrestrial life to migrate between continents freely. Megafauna used these corridors to spread, adapting their physiology to new regions. Fossil evidence paints a picture of specialized survival, not gradual decline. But ice ages do not last forever. The warming cycles eventually return. And the melt phase, known as an interglacial period, brings dramatic instability. The return of warmth allowed forests and different flora to rapidly recolonize. For many giants, the warming signaled extinction, unable to adapt quickly enough. And adaptations for extreme cold became liabilities in a warmer, wetter world. The sheer speed of the transition often outpaced evolutionary responses. Early human populations showed remarkable flexibility, shifting their focus constantly. They mastered complex clothing and shelter construction, key to surviving temperature swings. The rhythm of the Ice Age established the foundations of our modern biomes. Every river course, every valley, bears the scars of that immense abrasive power. The last major advance ended roughly 20,000 years ago, a blink in deep time. But we see these transitions repeated hundreds of thousands of times in Earth's deep record. Crucially, the orbital mechanics are predictable. We know when the next cooling phase begins. These astronomical drivers operate independently of current human atmospheric influences. However, human activity now adds a profound, rapid forcing onto this natural rhythm. Our contemporary environment is adapted to the warm interglacial period we currently inhabit. The Ice Age proves life adapts, but adaptation requires time. Time we are currently shortening. The Megafauna perished because the change was too rapid for their specialization. But the ancient cycles set the stage, but modern processes dictate the tempo now. But only the most generalized survivors remained when the giants vanished. But Earth's climate is a system of immense inertia, driven by celestial mechanics. The understanding the deep past ensures we respect the fragility of our current brief warmth.